this case over here, the one that we just drawn, it's not symmetrical about anywhere between point A and point B. Yes, right? It's not. On one side you have distributed load, and on the other side towards B you have P1 and you have P2. So can this be classified as symmetrical bending? Okay. So one thing I want you to take note. Okay. Symmetrical bending. Okay. Symmetrical bending has nothing to do with loading and geometry about the XY plane. So now what we are looking at is we are looking at the XY plane. So XY plane means we are looking. So if I were to draw I'll do rotation Z over here. I'll do my rotation Z. So this plane over here, this is what we call our XY plane. Okay. So symmetrical bending has nothing to do with the loading and geometry about the XY plane. Nothing to do with it. Okay. Then how is this classified as symmetrical bending? So I'm going to draw three different shapes for you. I'm going to draw, okay, in sense of time, okay, I'm just going to draw two. Okay, so one looks like this. Okay, so this is a centroid. Okay, so this is my Y, and this is my Z, right? So that is a centroid about my Z axis. Okay, then this is my centroid about the Y axis. So centroid along Z. This is our centroid along Y. Okay. Then I'll give you another geometry. Okay, I'll give you a geometry. Right. This is our geometry. So this is the other geometry. Same transformation. This is centroid along the Y-axis. And then over here, this is the centroid along the Y. Sorry, one, this is Z, and the other one is Y. Then I'm going to label all these points again. Okay, so I'm going to label this alpha, beta, I, and J. Okay, and then we are going to label this also alpha, beta, I, and J. Okay, and we're going to look at moment. Okay, we are going to look at moment. Okay, we are going to look at moment about Z. Okay, we're going to focus moment about Z. So likewise, let's say if we have a moment about Z. Okay, can anyone tell me, is this symmetrical bending? So we have cross section 1, and then we have cross section Number 2. Okay. Now, question for you. Is this symmetrical bending? Anyone? Is this symmetrical bending? Anyone? So you're like, sometimes the cross section is symmetry, sometimes it's not, right or no? Am I right? Is this symmetrical? Is this symmetrical bending? Anyone, please?
Yes.
It is. Why? You are right. But why do you call it? Why you say that it's symmetrical bending?
Because the centroid along the z-axis divides it into 2 even parts.
Okay. Anyone else?
I think it's not symmetrical bending because
And
the cross section is not symmetrical about the bending plane.
okay. So
Oh, sorry.
yes.
Is it because the bending moment's going to be positive and negative and be even values on both sides?
You're partly right, Christian. Okay, you're partly right. Okay. So now, what is symmetry? What is the rules for symmetrical bending? Okay. The rules, okay, whether symmetrical or unsymmetrical, is dependent on the stress field. Okay, it's dependent on the stress field. Nothing to do with, there are some aspect to do with geometry, but it's more on a stress field issue. Let me elaborate. Okay, so we see what we see over there is we know that stress X is equal to mz over izz multiplied by y, right? So for this case, there's only one moment. Okay, there's only one moment, which is mz, and the next thing is must be moment acting in one direction only. If it's two direction, it will never be symmetrical. Okay. Later on, we go into unsymmetrical loading, and you'll see why. So over here, what you will see, right? Let's look at cross section 1, right? So based on the moment arrow, we know that this is compression. This is down here is in what? Tensile. The same on the other diagram. This is compression, and this is what? Tensile. And the stress field is dependent on the y variable distance, right? The formula state that it's dependent on the y variable distance. Agree? So when that's the case, can someone tell me what is the stress field for alpha and beta for both cross section? If you look at alpha and beta, can someone tell me what's the stress field going to be like? Are they the same? Anyone? Are they the same? So I'm going to look at the chat now. Okay, are they the same? Yes. Okay, they are the same. So for this case, right, when we look at both of the structure, right, stress X alpha is equal to stress X beta, right? Both are, why they are the same? Because both are in what? Both are compression, right? And both have the same y magnitude. Okay, so the y magnitude are the same, yes or no? Right, the y magnitude are the same, right? So if you look at stress X I and stress X at J, they're also the what? They're also the same, because both of them are in tensile right? Both of them, the y value are the what? Are the same. In this context, when they satisfy this condition over here, when they satisfy this condition over here, this is what we call it symmetrical bending. Okay, this, oh, you guys can see, sorry. This is what, when this condition is satisfied, is what we call symmetrical bending. I got it wrong until 10 years ago. I thought it has something to do with shit. Something changed in Microsoft again. Do y'all see anything flip? Let me bring it back. Okay, it crashed again. Hold on. I'll try to get it back. Something changed, but I'll correct it later on. Okay, I can see weird stuff going on my computer. Right? Okay, now coming back, new window. Okay, something changed. Okay, so nothing to do with yes, nothing to do with the how the geometry has been loaded. Okay, had got nothing to do. Okay, got nothing to do with how the structure is loaded. Right, got nothing to do with how the structure is loaded, but has all to do with how how the structure is satisfying whether stress sorry, I should not be so distracted. It has all to do with the condition if stress x alpha is equal to stress x beta and stress xi is equal to what? Stress xj. Okay, so this thing has gone stupid. So stress x alpha is equal to stress x beta, stress x I is equal to stress xj. Okay, so this is the condition. Nothing to do with the what? With the loading. Okay, is that clear? I have to elaborate that. Okay, so nothing to do with how the structure is loaded. Okay, I'm going to draw this. Okay. Okay, so has nothing to do with what is going on. So it has nothing to do with this. Okay, it has nothing to do with what is going. So the structure can be loaded in any way or manner. Okay, it can be loaded in any way or manner. Does not matter. Okay, more important is the cross section. Okay, the cross section. If the left hand side, now we are dealing with moment about Z again. If the left hand side and the right hand side of the stress field are the same, we classified that as the symmetrical loading. Are we clear? Okay, that is very, very important. As I said, I used to get it wrong. Okay, so, and I don't want you all to be like me. Okay, get it wrong until now. Okay, so from here, I will do another. Yes.
Can we have example of an symmetrical one just to make it more clear?
Yeah, next week. Okay, this week is just one moment. Whether is it unsymmetrical or not, okay, it all depending on the moment acting in one direction only. Now, if we have moment in two direction, which is next week, I have to build up strong in one direction first. Okay, if I throw in one direction and show you two, then we pack up. Okay, then you guys, okay, we are packing up, we're done. Okay, right? Okay. So what I'm going to do now is we're going to look at another problem. Okay, still symmetrical bending. Okay, we're going to look at another problem. Okay, so what I'm going to do now, I think what is crashing this computer of mine. Yeah. Yes. Hello.
Sorry. What do you mean by stress field?
So stress field is stress magnitude. Hello.
Like, is it average? It's an average.
No. Stress field means for this case, stress x alpha is equal to stress x beta. That is the distribution, right? Okay, so what do I mean by that? Because they all share. So remember, we drew this, right? We drew this. This is known as a stress field. Yes or no? Can you see where I'm circling now? Hello? Can you see where I'm highlighting now?
Yeah.
That is what we call stress field. Okay, so when the magnitude at point stress x alpha is equal to stress x beta,